In this presentation, we'll be covering the stage modeling topic. And taking a quick look at the agenda here, we'll be looking at what is stage modeling. We'll take a look at model-based definition of your stage models and consumption of stage models next. And then we'll wrap up the conversation talking about flexible licensing options for your stage modeling application. Jumping into our first topic, what is stage modeling? We'll take a look at the following topics. What is stage modeling's role inside of manufacturing? What is the user experience like inside the NX environment? Stage model definition, creation, and management. So looking at our first topic here, stage models' role in manufacturing. If we look at the diagram down below, we can see in bright orange there the word stage model creation. This is the process of creating from your finished production part the stages of manufacturing going back in time. There are other options as well. You can do a hybrid design approach here using a finished production part and an as-cast part, and then creating the manufacturing stages in between. Where stage modeling lives inside of the manufacturing process here, you can see the designer is working on the stage models. Those are created, and then those can be sent back to process planning authoring, or they can be sent on to machining, inspection, line optimization, or fixture design processes. And if there's any changes that needed to be made there, those can also be sent back around to the work instructions or back up to the process plan authoring once again and sent back into stage models if there's any changes that need to be made there. What the stage models are going to allow the user to do is create the different stages for manufacturing, and those different stages can be shared amongst these other groups and other team members to go ahead and start doing their part of the job. If we look at the user experience here, there's a simple user interface, very familiar interface inside the NX environment. Stage model application is its own application inside the software. You would enter stage modeling application. Once you do that, the stage model set concept is going to contain all of the stages and the engineering data selected for stage models creation. Associative links will be created between the different stages, and those are going to be easy to capture and send information into another manufacturing stage. Our stage model navigator is used to track content of all the stages in a single navigation tool here. For example, your features, your model views, your PMI, your rules, and your dependencies will all be located over here in the stage model navigator. All of your standard model-based or MB3 capabilities are available to access and edit the content. Stage model navigation of all the stages and direct actions like activating a stage is easy to go ahead and do by jumping back and forth to the different stages. If you want to work in a stage, all you have to do is click into that stage's window and activate that stage and make modifications for that stage. The entire stage modeling process is going to be performed inside an easy-to-use environment here. That is the stage modeling application. If you look at the windows over to the right here, you can see the stage model navigator is going to be on the left-hand side. The next section over, you're going to see a different representation or capability to present that with a more graphical picture of the different manufacturing stage if you want to present it that way inside the stage model navigator. Over to the far right, you'll see a couple of windows that are stacked there. As you start to create additional stages here inside the software, it's going to open up another window, and you can use the multi-window setup inside of the NX application to see all of your stages and parts side by side here inside the same window. Taking a look at our next topic here, model-based definition of the stage models. We'll take a look at the top-down design approach first, then we'll look at the hybrid design approach, take a look at an option for model comparison between the different stages, and then finally we'll look at the model-based definition of the stage models. Getting into our first design approach here, which is the top-down. The top-down design approach is going to allow you to take a finished production part, and we can go ahead and rapidly define the different stages or manufacturing stages by reusing that information from the finished production part. The interactive stage model set can be created. We can add stages, delete stages, etc. So if I start to create these stages and I start to work with my production team, the manufacturing team, and they say, well, we need an additional stage here to go ahead and machine this part of that design, we can go right back in and add an additional stage very easily. If the manufacturing team comes back and says, well, we can consolidate a couple of these manufacturing processes into a single stage here, now we can go right back in and delete some stages that might not be necessary. We can also leverage modeling capabilities to define the geometric shapes of our stage models. For example, we can copy geometry with an associative link, we can use synchronous technology, and we can use our other modeling operations as well. The stage modeling operation here eliminates many manual modeling methods to complete the stage models, resulting in greater productivity improvements. So jumping into our first demonstration here, we're going to take a look at the top-down approach for utilizing stage modeling. So as you can see, we do have a finished production part, and we also have some different views here with some PMI embedded on the part. So the application is called Stage Modeling. We'll go into Application, open up Stage Modeling Application. Once we open that up, we want to go ahead and create a stage model set first. So we're going to activate the stage model set. We can type in our number of stages here. We can give that a descriptive name. Once we do that, we'll select OK and begin creating our stage model set. Now, if you look at the Stage Model Navigator over on the left-hand side, you can see we have all of our different stages. Now inside the main graphics display, we're going to reuse some geometry here. So we're going to link this geometry into our first stage. We'll edit that stage. We can give that a descriptive name here for that stage, maybe what is happening at this stage or manufacturing process. In this case, we're milling out 4 pockets from the top of our part. We can give that a more detailed description down below as well. Once we're done editing our properties here, we'll go ahead and select OK. And now you can see there's my information or my new name applied to that stage. Now we're going to go up here and apply some group faces here. And we're going to group a couple of these faces together. So I'm going to pick this face here, this third face, and then this 4th pocket face set here. Now once we do that, we've applied a feature color to those grouped faces. This is some visual feedback for somebody that opens up this part, and they can see immediately what's being milled out at this manufacturing stage. Now we're going to reuse some PMI here. We're going to select the PMI from the finished production part, and we'll inherit that downstream into the first stage. Once we select the PMI, whether that's in the finished production part or over in the first stage part, you can see it highlights in the other part. So you can see that direct relationship that was created when we reuse the PMI into the other stage. Also over in the Stage Model Navigator, you can see we have our PMI category, and I can navigate through my different PMI that's been applied at that stage. We'll go ahead and save our part here, and next we're going to jump over and work on our next stage. So if we go into the Stage Model Navigator, we can right-click and we can activate that stage as the current stage we'll be working in. Using the multi-window layout here, now we can go ahead and display all 3 of those windows at the same time. So as you can see, it's very easy to show all the different manufacturing steps on the screen at the same time here. We're going to go ahead and use some synchronous technology, and we're going to delete some of these faces off. We'll use the boss and pocket face selection rule. We'll pick one of those faces and pick the pocket faces here and delete those off this stage. Now these features do not exist at this stage. We're going to be jumping in and selecting a different group of faces here. So we'll use the boss or pocket face option. We'll pick the single face that's going to pick all the pocket faces and assign the green color to those faces. Once we do that, we can very easily see, if we open up this part file, what is being machined at this particular manufacturing stage. Now we can go in to edit some of the parameters here and apply some different information for maybe the name and give that a nice description. So another user that can open up this part file, they can see exactly what's happening at this manufacturing stage. And this is stage 2, so we want to add stage 2 to the end of that. Now we're going to reuse some PMI from a previous stage here. So we're going to jump over to our finished production part. We're going to grab some of the PMI elements here, select those, and you can see those are going to jump over into our active manufacturing stage. We'll save our part and continue with the process here. Now, as you can see, we can continuously jump into the next stage, rearrange our windows here using the multi-window setup, and so I can see all my stages now at the same time. Now I'm going to speed this up just a little bit here and fast forward in time. Now when we get to this next step, we're going to demonstrate how we can add tooling stock or stock back to the part at a previous stage. So we're going to pick the outside faces on this stage here, and we picked the boss faces. So we picked the selection intent rule was set to boss faces, and we picked all the outside boss faces. Then we chose a single face at the base. Now at this stage, we might want to go ahead and add some additional tooling stock here. We can do that by using some synchronous technology commands, but first we're going to go ahead and reuse some of the PMI. So let's go ahead and apply some of this PMI from the finished production part view over into our current stage. As you can see, the size is 11.738, and it's going to be larger over in that production stage because we've added some tooling stock to that body. The nice thing about this is that there is direct associativity because that is a wavelength body from one of the previous stages. Jumping ahead in time here, as we get down to the end of our finished production part, we get down to the stock, we can use the derived stock option here. We can select the stage to examine, and now we can go ahead and give some different positive clearance or negative clearance on that stock, and it's going to generate the body for us and give us our overall envelope or our starting stock piece to begin the manufacturing process with. All right, so that was the top-down design approach here. The next one we're going to look at is the hybrid design approach. With the hybrid design approach, essentially we're taking the finished production part, and we can also start with the as-cast part, and we can do the modeling stages in between or the manufacturing stages in between those two parts. We can utilize the stage modeling approach starting from that completed production part, and then also have an as-cast part, and we can use some tooling bodies from the finished production part. We can wavelink the as-cast part into a stage, use some tooling bodies from the finished production part to subtract material away from the as-cast part, and so on and so forth. So jumping into our demonstration of this process, this is the hybrid design approach. Over on the left, we have a crank as cast. We also have a crank as design with the tool bodies. As you can see, we do have some tool bodies inside of the finished production part. And we'll go ahead and start our stage modeling application. So jumping into our stage model set, we will prescribe the number of stages we'll need here. We're also going to pick on the part that we want to start with. So we're going to start with the crank as cast part, designate one stage, and then select OK. We're going to edit that stage and give this an op name here. So this may be operation 10. Give that a description here. So this might be the flange machining operation. Now we'll link the geometry from the finished production part and the as cast part into that stage. So we'll start with the as cast part and send that into the part file here. Next, we'll go ahead and use some tool bodies from the finished production part and link those into this manufacturing stage. So we use these two end pieces here, this geometry here, and we'll use some Boolean operations to subtract that material away from the as cast part. So our target body being the as cast, the tool body being the actual body we imported from the finished production part. We can create a new stage very easily. Just right click on operation 10 and choose new stage. Now we're going to create operation 20. We can type in a description for this operation and then select OK. Change our window layout to show all 4 stages. Our finished production part, as cast part, stage 1, and then stage 2. We'll select our linked body, send that downstream. And now we'll go ahead and use another tool body from our finish production part here. So as we're doing this, you can see how easy it is to reuse information from multiple parts if you need to do that. In this case, we're using some tool bodies from the finished production part, sending that into a stage, and we need to add some offset here to these interior cylindrical faces. So we're going to go ahead and add a little bit of offset here, 0.35. We'll flip the direction and then select OK. Once we do that, we use a subtraction Boolean operation, pick our target body, and then pick our tool bodies here to subtract that material away and machine that material away at this stage. All right, so for time's sake, I'm going to speed this up a little bit here. Now, as you continue to create additional stages, you can have as many of those stages presented in the windows here as you would like. Just go up to your View tab and rearrange the windows so you can see all those different stages with the multi-window setup here. All right, jumping into our next topic here, the Model Compare tool. So we can graphically compare our geometries between two different stages with this tool. We can generate a comparison report, and when you do open up this tool, you'll see that it's very easy to see the differences between the two different stages. Maybe something that's absent from a stage, something that's changed on a stage, something that is new, or something that is the same on both of those stages. Jumping into this demonstration here, we will take a look at the Model Compare tool. So jumping into our Compare Body tool under the Analysis tab here, the first thing you want to do is select the Control Body or Stage, and then the Sample Body or Stage. Once we select the Compare button here, it's going to open up a dedicated window. We can make that larger if we drag that off the tab bar, and we can go ahead and scale that up to focus on the comparison that's being made here. Now on the Compare Body tool here, you can see we have a capability down below in the settings to change the colors of things that are absent, items that are changed between the two, new items, as well as looking at the items that are same here. So we have the red color for absent, yellow for that change, and anything that's new will have the green surfaces, and the items that are the same between both bodies are going to have the gray appearance. You can use the slider here to fade and show more of the control or the sample over in the right-hand window. So that is the Model Compare tool. Definitely take advantage of that. It's going to help to eliminate mistakes, and you can see what's changed between the different stages very easy and do those comparisons with that analysis tool. The next item we'll talk about here is model-based definition of the stage models. This is going to allow us to capture manufacturing information on the 3D stage models. We can reuse PMI to repurpose manufacturing information from the design parts with the associative links. We can also leverage NX model-based definition capabilities to author and execute user-defined rules on the stage models. We can use stage model-specific rules that are delivered out of the box with the software here. So in the image that you see there with the stacked boxes with those splines going to each box, this is what is called a rule-based setup here. So this is a rule that is being defined. We can apply this rule to the model-based definition or to the part and apply the model-based definition. And this is going to be inside of the reuse library to easily access for other parts. So this allows for rapid definition of the stage models with captured manufacturing information, which is going to lead to a significant productivity gain. Jumping into a quick demonstration here, we'll take a look at using some of those rules. So in our reuse library, we'll look at some of our logical rules. We'll go down to the stage model category here, and we'll use the stage model fit tolerance rule here. Now with that stage model modify fit tolerance, we can apply this and pick some features on one of the stages and quickly apply this fit tolerance to those features. So we'll pick some of the features on one of our stages here. Once we select those features and then go ahead and prescribe our settings in there, we'll select OK. And you'll see all those parts flash because there's a direct relationship and the software finds those features on one of the other stages here. And it applies those different tolerances or PMI items to those items on that stage. So this is going to save a lot of time because the software is looking across all of your stages and it's quickly applying these PMI items to the related features at all the different stages. We can go back in and make a quick change if we need to do that. And once we make that change, we can update all that information as well. All right, taking a look at our next topic here, consumption of stage models. So once we start to create these different stages, we can reuse the information, which is easily parsed out to different team members here. So what's nice about that is I can create my different stages and I can send a stage off to one of my other team members, somebody that's maybe setting up some inspection rules here and inspection programming. And I can go ahead and share that part file. They can open that up and begin doing their part of the job. I can send one of the stages out to somebody to start creating a manufacturing drawing with. Also, I can send a stage out to somebody that's going to be setting up some CNC programming. So we can reuse this information, reuse all the information that's embedded at that stage, including the PMI, and have our other colleagues working on their part of the job while I'm finishing up the stage creation process. So jumping into a demonstration of this, we're going to reuse some information here, and we're going to reuse one of these stages. So for our rules demo 1, 2, we're going to go ahead and create a new inspection part file here. I'm going to go ahead and select OK. Once we open up this part inside of the inspection program here, you will see that we can easily link to the PMI from that stage. Once we select OK, the software is going to read the PMI information that's been applied to the part at that stage, and it's going to quickly add all the tolerances for me on my features, set up my inspection paths, and also recognize all the features on that part. So this can potentially save up to 80% of your time by reusing this information from one of the stages in another operation. For this example, we're using the inspection process, and you can see we were able to link to that PMI and quickly generate all these inspection paths on our part. All right, jumping into our final topic here, we will talk about the licensing for stage modeling. So stage modeling is an NX add-on module here. It is its own dedicated application inside the software. If we look at the capabilities here, that includes stage model definition, our entire user experience that you saw here, including PMI reuse and derived stock options. Stage modeling was introduced in NX 1953, so if you have 1953 or a newer release, you can get the add-on bundle for stage modeling here if you'd like to do that. The product name and pricing here. So our product name is NX Stage Model. You can reach out to us here at Swoosh if you want pricing on that product. This is also available to be used with tokens. So if you have not heard of the token system here, you can buy a pack of 50 or 100 tokens. You can use maybe a certain set of tokens. If you need to open up stage modeling, it's going to pull that number of tokens required from the pool of tokens. Once you're done with stage modeling, you can close stage modeling application down. It places those tokens back into the pool. Now another user, they can open up their software and they can use stage modeling and pull those tokens from the pool. So that is available with tokens as well here. Some prerequisites, any NX or UG bundles containing gateway. This also requires modeling, PMI, NX model-based definition to complete the workflow that you saw here today. All right, a quick summary of benefits before we wrap this up. Stage modeling is easy to use. It's very easy and familiar interface. If you've done modeling or drafting inside of NX, you're going to have that stage modeling navigator. It's a very similar process and in a very similar environment. The definition, creation, and management of your stage models is going to help to improve efficiency here with your operations. Now, leveraging NX model-based definition stage model environment drives rapid authoring of the downstream manufacturing information on those stage models. And finally, these stage models consumed directly in downstream applications are going to help to automate manufacturing processes here. It's going to allow you to send these different stages off to other colleagues. They can do their job, and you can continue working on the design of the part. If they need to have something changed at a stage, they can come back and you can make that change. They can update that stage, and now it's going to update their process as well. Okay, that's going to conclude the presentation. Once again, thank you for watching. And that will conclude our NX University 2022 presentations this year. So again, thank you for watching the presentation. Thank you for being a part of NX University 2022 sessions. And we look forward to seeing you here again next year.